Good day, algebra students. This is a quick video that will show us exactly what we need to know before we get into Algebra 1 in the fall. So this is intended as a summer assignment. The purpose of the assignment is to go over those pre-algebra skills that, you know, having gone through your 8th grade math class, you might need to review before beginning Algebra 1. Now, all you need for this assignment is something to write with. We will avoid the use of a calculator because the purpose here is to develop numerical literacy and number sense and not necessarily focus on those calculator skills just yet, though we will be working on those extensively during the year. So getting into the assignment, this assignment is structured in the same manner that your builder assignments were structured last year. So we will just dive in and begin and see what each question is asking us to do. And then I will show you the way I want you to show your solutions. So the first two questions are just asking us to add two numbers. Sometimes on this camera, the decimal points aren't very clear. So for these first two problems, it's 2.1 plus 0.3, and then 1 plus 6.5. These are both trivial to solve on a calculator, but let's just solve them, or let's just evaluate them using paper and pencil, or in this case, paper and pen. You'll notice that I've got this ruler here. I will require you to write neatly. Okay, so neat writing is as important to being successful in the math class as getting the correct answer, which is, of course, very important. But doing so in a very neat way is a prerequisite for success in the class. Neat writing means neat thinking. So, with that in mind, let's add 2.1 and 3.3 and 0.3. Okay, so just set up this stack add here. We line up the decimal points. So I know that there's going to be a decimal point right there. In the right column, I add 1 and 3 and get 4. And then over here, I don't have a term on the lower row, so it's just 2 plus nothing, 2 plus 0 equals 2. So 2.1 plus 0.3 is 2.4. Next problem, number 2, we have 1 plus 6.5. Now, when doing this on a calculator, again, it's trivial, but on paper, I see a lot of mistakes, and I want you to avoid them. Let's look at the problem. Here, I've got a whole number, no decimal, and then the second term of the sum has a decimal. So I want to look at that decimal. It goes out to the tenths place. So rather than just writing a 1, I want to write 1.0. And that's important for placement because when I add 6.5 to it, I don't want that 0.5 just hanging out by itself. I want it to be underneath that 0. Okay, so now let's add 0 plus 5 is 5. Make sure you put your decimal point where it goes, and then 1 plus 6 is 7. 7.5. Now, typically when we show answers in Algebra 1, if there is an answer like this, you will put that answer in a box. So for these two problems, as you're doing this, make sure you're putting your answer in a box. So it's very clear to the teacher just what you think the answer is. Obviously, if it's multiple choice, this is less important, but still on multiple choice problems, you'll have to show as much work as if there weren't multiple choice. And in all cases, I want to see the answers in boxes. Okay, number 3. We're asked to evaluate this fractional expression, and I'm given negative 5/3 minus negative 3/5. Okay, so before we do anything, we need to rewrite this without the parentheses so it's clear just what we're doing. So the first step is to rewrite. I'll rewrite negative 5/3 in parentheses as just negative 5/3. And then I have to deal with this minus minus. So rather than writing minus minus, I'll write plus because a minus and a minus is a plus. So negative 5/3 plus 3/5. Before we can evaluate this, we have to find a common denominator. Right now I've got a denominator of 3 here and a denominator of 5 here. So I've got to find a common denominator, and to do that, I've got to find the lowest common denominator between 3 and 5. If you don't know what that is, there's a simple way that you can figure it out. So come up here and make 2 little columns, one for 3 and one for 5. This is just a quick way to do this. So 3 times 1 is 3. Okay. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. And then we'll go to 5. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. Okay, there I've found it. My lowest common denominator is 15. So the question becomes, what do I have to multiply negative 5/3 by to get a common denominator of 15? And what do I have to multiply 3/5 by to get a common denominator of 15? It's a different number for both fractions. In the case of negative 5/3, I have to multiply the denominator by 5 in order to make that 3 turn into a 15. But I can't just multiply the denominator by 5. I have to multiply the numerator and the denominator by the same number. So we have to multiply 5/5 by negative 5/3. Okay, we'll put that in parentheses so it's clear that it's a separate little problem on its own. And then we add. And now we do the same thing for 3/5. I've got to multiply 5 times 3 to get 15, but I must also multiply 3 times 3 in order to keep the numerator and denominator 3/3. You see, because essentially I'm multiplying both of these terms by 1. 5/5 is just 1. 3/3 is just 1. So here again, make a little open parentheses and then 3/3 times 3/5. Okay, keeping in mind the neat handwriting, keeping in mind showing all the steps so I can see what's going on in your brain. Now we just multiply across. So it's 5 times negative 5. That's negative 25. 5 times 3 is 15. So I've got negative 25/15, which is reducible back down to negative 5/3. just divide the top and the bottom by 5, you get negative 5/3. So we haven't actually changed the fraction, we've just changed its denominator and numerator by scaling it a little bit. Now we'll add, now I multiply 3 times 3, I get 9 over 3 times 5, 15. And now that we have a common denominator, we can add the numerators. So now we have to add negative 25 and 9. Well, what is negative 25 plus 9? If we are adding this without a calculator, sometimes it's not exactly obvious. We start with negative 25, okay, on a number line. And am I moving to the right or to the left? Because I'm adding 9, I'm actually moving to the right 9 spaces. Okay, so I'm going to have a negative number because the negative 25 is bigger than 9, but it's going to be smaller than negative 25. It's going to be closer to the 0. So when we perform this, it looks like a subtraction. The way that you'll do it in reality. 25 minus 9. And then you'll just stick whatever 25 minus 9 is, you'll stick a negative sign in front of it. So in order to subtract 9 from 25, we have to borrow from the tens column, okay, and that becomes a 1, and then this 5 becomes a 15. And 15 minus 9 is 6. 1 minus nothing, 0, is 1. So we have negative 16 because we put that negative sign back. Now, negative 25 plus 9 is negative 16 over 15. Now, is this the final answer? Well, it all depends on what you've been asked to do. That is, in fact, correct, but that's an improper fraction. So if I wanted to express my answer as an improper fraction, I'm done. If I wanted to express my answer as a proper fraction, I would write it like this. We have to think. Can I pull a 1 out of this? All right. So the question is, what would pulling a 1 out of negative 16 over 15 look like? Right. So the way to do it is you subtract 15 fifteenths. And if you subtract 15 fifteenths, you are left with, so I'm going to just write this in proper fraction form over here. So it all depends. That's improper fraction, that's correct. But the proper fraction form would be negative 1 and 1/15. Okay, that's something we'll have to work on a little bit. This is like a mixed fraction. And the way that you know it's correct is you multiply the denominator by the whole number. So you got negative 15, 15 times negative 1, plus the numerator. So I've got negative 15 plus 1 is negative 16 over 15. And that's how I know it's correct. Okay, so both of these are correct. We'll put them in boxes. And when you're converting from improper to mixed or proper fraction form, you kind of ignore that negative symbol until the very end. So those are the same thing. Let's do the same thing for number 4. So here, get rid of these parentheses first. I've got 1/3 plus negative 5/6. Well, first thing I can do is rewrite that. I'm going to indicate that I'm merely rewriting something by putting a little arrow like that. It's like an equal sign with an arrow on it. So 1/3 plus negative 5/6 is the same as 1/3 minus 5/6. Again, we've got the problem of common denominators. So the question is, what do I have to multiply by 3 to make 6? Because in this case, 6 is the lowest common denominator, right? What would I have to multiply this denominator by 3 to make 6? Well, the answer is 2. I have to multiply 1/3 by 2 over 2. So use a different color here. 2 over 2. Just a different way of doing this. And that's a multiplication. And then over here for 5/6, what do I have to do to make the 6 into a 6? Well, I don't have to do anything to it. Okay, so you could write multiply by 1 over 1, but you don't really need to write that. You can just leave it. So now 2 times 1, I'm going to rewrite here. 2 times 1 is 2. 2 times 3 is 6. So 2/6. Reducible back down to 1/3 by dividing the top and the bottom by 2. Okay, so we're in business. 2/6 minus 5/6. Now it's just a matter, because I've got a common denominator, of subtracting 5 from 2. Now when I subtract 5 from 2, what's happening on the number line? Okay, think about it visually. You've got 2, okay, up here, and I'm subtracting 5 from it. So I'm moving to the left on the number line. I'll pass through 0. And so what is 2 minus 5? Well, it's like 2. If you ever need to do this, don't feel ashamed. It's 2, 1, 0, -1, -2, -3. Okay, that brings us down to -3. 2, 1, 0, there's the 0. And now we're into negative territory, we're at -3. So -3 over 6, because we don't do anything with those denominators. Now we're not done yet, because -3 over 6 is not in its fully reduced form. These two numbers, 3 and 6, have a common factor. Okay, what is a factor? Well, here's what factors are. If we take 3 and we break it down, we can get 3 by multiplying 1 and 3. If we take 6 and we break it down, we can get 6 by multiplying 2 and 3. The common factor is 3. So what that means is that I can reduce this fraction, -3/6, by dividing both the numerator and the denominator by the greatest common factor, which in this case is 3. So that will reduce the fraction down. So -3 divided by 3, we'll just put an equal sign here. -3 divided by 3 is -1. And 6 divided by 3 is 2. Okay, so the reduced fraction is -1/2. Put that in a box. All right, very good. Next up, we have another problem. And in this problem, we're mixing a whole number with a fraction. This is something that really tends to mess with people's heads. So I want to go through this with you and make sure you understand what to do and why we do it. All right, so first let's clean up the notation. We'll put that little arrow symbol. We're going to rewrite this as 2, and then minus minus is a plus. 2 plus 1/3. one of the more common things I hear is that the answer is 2 1/3. And that's just not correct, okay? Because we cannot add a whole number to a fraction. We can't just put them together like that. You have to turn this whole number rather, into a fraction with 3 as its exponent. And so before we can even begin to do that, we've got to understand how we can write whole numbers. So this is one of those things we just have to learn. 2 can be rewritten as a fraction as 2/1. And that's a skill we'll practice a lot, just rewriting whole numbers as fractions. So now what we'll do is we will rewrite, we'll rewrite 2 as 2/1, 2/1 plus 1/3. Well, if you made it this far, you know what we're going to do next. We're going to find a common denominator between 1 and 3. The lowest common denominator between 1 and 3 is 3. So we're going to multiply 2/1 by 3/3. Okay, so 3/3. Just kind of stick it in there. So 2 times 3 is 6. 3 times 1 is 3. 6/3 is the same thing as 2/1. Divide both sides, the top and the bottom rather, by 3, you get back down to 2/1. So 6/3 is just 2. Written as an improper fraction with 3 as the denominator, because we needed 3 to be in the denominator position. So now we'll add to that 1/3. Now that we have common denominators, we can evaluate the expression by combining the numerators. 6 plus 1 is 7. And then the denominators just come along for the ride. We don't add them. So 7/3. Okay, so now it's a little bit of a reveal. Back to what we started with talking about. That is the improper fraction version. So let's write this now in the mixed fraction version notation that we've learned. So the question is, if you want to write something in its mixed fraction form, you have to do what the fraction is telling you to do. So 7/3, fine, it's an improper fraction, but if I asked you to express it as a mixed fraction or proper fraction, you're going to have to do something with this. And the way you do it is you take 7, right, and you divide by 3. It's a simple division problem. Question is, how many times 3 go into 7? 3 goes into 7 2 times. 2 times 3 is 6. Okay, and then just perform the longhand division. 7 minus 6 is 1. Now, stop there. If you ever wanted to know what to do, right, when you're doing this, you take your whole number of your quotient, which is 2, and you write that right here, 2. And then you have to, it seems like a lot of people don't know what to do here. You take your remainder value and you put it in the numerator position of a fraction that sits out to the right of the whole number. Let me show you what this looks like. So we're going to take this remainder value right here, and I'm going to stick it in the numerator position, right? So the 1 goes here. And then I'll take my divisor right here, okay? I'll take my divisor right here, and I will put it in the denominator position right there. So the answer is 2 1/3 as a proper fraction. So It's a little bit of a trick, right? Because 2 plus 1/3 is 2 1/3. But if we only approached adding fractions that way, you would miss this process of getting an improper fraction and then converting that back to a proper fraction. Okay, so in this problem, we were asked to give an improper fraction, but I wanted to show both ways that 7/3 and 2 1/3 are equivalent. Okay, so study this diagram carefully. These problems get harder over time, and you need to know what to do with that remainder value in the divisor in order to create a proper fraction. Okay, so now on to number 6. Number 6, we have 8/7 minus -1/2. So write this out again as 8/7 minus -1/2. So minus minus a plus, so 8/7 plus 1/2. Okay, we can't add this yet because we don't have common denominator. So let's find a common denominator. What is the lowest common denominator between 7 and 2? Well, like I said before, we will list out all of the multiples of 7 and 2 until we get a common one. So 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. We'll do the same thing for 2. 2 times 1 is 2. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. 2 times 6 is 12. 2 times 7 is 14. So bingo, there is my common denominator there, 14, the lowest common denominator. Okay, right here, this is the LCM. I wrote LCM. The lowest common denominator, LCD, lowest common denominator. Okay, so now we got to perform our little surgery on our fractions in order to get a common denominator. So 8/7, I'll multiply 8/7 by 2/2 because 2 times 7 is 14. I want this to be a 14. So I'm looking down here and say, what do I have to multiply by 7 to make it 14? 2. So that means I've got to multiply the top and the bottom, okay, by 2. And you end up with this little math problem. And then to that, we will add another little math problem. In this case, we've got to convert 1/2 to something with a 14 in the denominator. Well, what do I have to multiply by 2 to get 14? 7. So I'll multiply 7/7 by 1/2. Multiply 7/7 by 1/2. Okay, let's perform that. That's going to equal 2 times 8 is 16 over 2 times 7, which is 14. All right, so just a quick point. When you're multiplying fractions, you do multiply the denominators. When you're adding or subtracting fractions, you do not do anything to the denominator, assuming it's common, right? Okay, so plus 7 times 1 is 7. 7 times 2 is 14. Okay, so that's our problem now. 16/14 plus 7/14. So just rewrite 16/14 14 plus 7 over 14 equals, what's 16 plus 7? Well, over in our side work area, we'll add 7 and 16. See what we get. 16 plus 7. 6 plus 7 is 13. Carry the 1. Okay, so you've got 1 plus 0 plus 1, that's 2. 16 plus 7 is 23. So you end up with 23 over 14. Now again, we could stop there and leave this thing in improper fraction form. But if I ask you to turn this into a mixed fraction, we want to make sure we understand exactly how to do that. So in order to do that, we'll divide 23 by 14. Okay, this is pretty simple. 14 goes into 23 one time. Okay, so you just put a 1 there. 1 times 14 is 14. And what is 23 minus 14? Well, if you don't know, you just do the little subtraction, borrow the 10 from the tens place there. That becomes a 1. So now I've got, oops, meant to write 13. So now I've got 13 minus 4 is 9. And 1 minus 1 is 0. All right, because we borrowed from the tens place. So 23 minus 14 is 9. So here's the deal. Here's the deal. I have the whole number of the quotient, 1. Right, so I'll write this down here. I have 1 as the whole number of the quotient. And then this remainder becomes the numerator of a fraction out to the right of the whole number of the quotient. And then this divisor, 14, goes here. So 23 fourteenths is equal to 1 and 9 fourteenths. So again, these are equivalent. If you ever wanted to check, you multiply 14 times 1, that's 14, plus 9, that's 23. And you get 23 fourteenths. So these are equivalent. And you will be asked throughout the year to express your answers using either proper or improper fraction form, mixed fraction or improper fraction form. So these two things are equivalent. These are equal. Okay, so numbers 7 and 8 you do on your own. Okay, and what you're going to do is you're going to do these on your own, and on remind, send them to me on remind. Okay, your answers to numbers 7 and 8. So this is you do. Okay, you do these. You do and you do. You do number 7 and number 8. And then on remind, text me what you get as answers. And I'll check it. I'll check your work. And the way you do this, if you haven't ever worked with me on remind before, just do the work on a piece of paper, show your work, and then take a little picture of it. And send me that picture of the problem with the answer in a box on remind. So for you guys, you'll be sending me either one picture with 2 problems or 2 separate pictures, one with each of these. Okay, so that gets us through the first page, and we'll stop there and pick up with the second page in the next part.